Alright guys, the objective of this lesson is to solve trig equations by using the double angle formulas. The reason you have to use a double angle formula is because you're asked to solve for theta, but the functions that are given in the problem, one of them involves theta and the other one involves 2 theta. For you to be able to solve this problem the way we have been, they both need to involve theta, not 2 theta. So what you're going to do is take the function that has the 2 theta in it and replace it using one of the double angle formulas. Now sine 2 theta only has one possibility. Sine 2 theta is equivalent to 2 sine theta cosine theta. If you bring down the cosine theta from above, you see that it's similar to what we've been doing. This is a trig equation. Normally what we want to do is get only one function in the equation, but you can also see that that's not going to be possible in this case. There's nothing you can replace cosine or sine or just cosine with. None of them are squared. If they were squared, perhaps you could use the Pythagorean identities. That's not possible here. So this particular question, the only way to really solve it is to look at cosine and take it out of this expression on the left of the equal sign as the GCF. If we do that, even if we're not getting just one function, we're able to get 2 factors where each factor has one function. So we have now cosine theta equals 0 and 1 minus 2 sine theta equals 0, and you can solve each of those individually. The first one is going to give you 90 and 270. The second one is going to give you sine of theta equals 1/2, and therefore theta equals 30 and 150. Once again, this is not a typical quadratic trig equation, yet the only way to solve it was by factoring. But before any factoring was involved, we needed to make sure that the function that contained the double angle was rewritten so that there was only single angles in it. Okay, the objective is here as well to take the function that contains the double angle and replace it with an expression that's equivalent that only has a single angle. Now for cosine 2 theta, we actually have 3 different options. We have cosine squared theta minus sine squared theta. We have 2 cosine squared theta minus 1, and we have 1 minus 2 sine squared theta. So we have 3 different possibilities with which we can replace cosine 2 theta. Now, how do you choose wisely from these 3? Well, it would be really convenient if the entire equation had only one function. If I choose the first option, I'll have both cosine squared and sine squared. If I choose the last option, I'll have sine squared with the original cosine that was there, so we don't want this one. However, if we chose the middle option, then our equation would contain only cosine throughout. It would become 2 cosine squared minus 1 plus 2 cosine equals 0. Now you can distribute the 3. If you follow through on the algebra, you're going to use quadratic formula. The final answers to this problem should be 153, 267, 56, and 304.